Hi, my name is Jake Liu. I am a senior application engineer at Teledyne DAOSA. I am going to introduce the exsync fractional multiplier divider in this video. By far, we used to use only integer exsync multiplier divider. The fractional exsync multiplier divider is a new feature introduced to all models of Linea HS cameras. The fractional exsync provides more accurate exsync than the integer exsync, so that a user can achieve finer color or channel alignment. This new feature works only with the camera I/O for now. The camera I/O accepts only TTL type of signal, so you have to form your exsync as a TTL signal. Here is an example of a Shaft encoder. In general, Shaft encoder provides a phase signal as A plus, A minus, B plus, and B minus. You can pick up one of them to be connected to the camera I/O. I choose phase A plus connected to the camera I/O pin 5, which is a channel that accepts phase A. Camera and shaft encoder signal grounds must be connected. Camera I/O pin 11 and 12 are signal grounds of the camera. You can connect the encoder signal ground to either pin 11 or pin 12 or both. Now let's take a look at the frame grabber configuration. All Linea HS camera are required to work with XTM2 CLHS PXA frame grabber. Choose Camera Link HS Color RGB and load a pre-configured camera file called CCF file. You can download CCF files from the Teledyne DAOSA website or contact your local technical support. If you do not have a CCF file, you can configure parameters manually. Just set all parameters as what you are seeing in this video, and you can start from there. As I've mentioned, fractional exsync has to be fed through the camera I/O, but not the frame grabber. So I am going to select None here, line sync source. Also, I'm not going to use the external frame trigger. Select Disabled. Image buffer parameters, leave it as shown. Now let's take a look at the camera part. The camera testing here is Linea HS16 color. Let's move to the camera control category. In the TDI mode, select TDI BGR. This color order isn't the RGB order we are familiar with, but don't worry, the frame grabber handles it right. Next, digital I/O control category. In the trigger mode, select external. In the trigger source, select line 1. By the way, CLHS in is using when feed the exsync through a frame grabber. Lottery encoder. Literally, it's for an encoder. Okay, choose line 1. In trigger input line activation, you can select a rising edge or falling edge or both edge. The both edge feeds the camera 2 times trigger pulses compared to rising or falling edge. Let's try the rising edge. Before we try the fractional multiplier divider, let's try the integer multiplier divider first. Choose multiplier divider and look at the image output. big offset between colors. Try to change multiplier and divider values to find the best combination available. The image looks worse. Try something else. Getting better, but still not so good. Here you go. Pretty good now. However, you still can see subtle misalignment. Now let's try the new function, the fractional multiplier divider. Set both integer multiplier and divider to 1 time, and select fractional multiplier divider from lottery encoder rescaler order. A lot of shifts. First, change the tens digit. Let's try 3 and see how it goes. Getting better. Second, change the hundredths digit. Change it from 0 to 1, much better. Change it to 1.32. Here you go. It is almost perfect. Let's zoom in and take a look. Let me try 1.33. Now it's separating in the other direction. The number 1.32 is the best parameter for this system with the current settings. The optimal parameters are depending on the system. The optimal parameters of your system should be found by yourself through experimentation. In addition, let me explain how to configure strobe light control. You can output the line trigger pulses to the light through the camera I/O, line 3, 4, 5, and 6. In this example, I connected a strobe light to line 3, so you can control the light source by the line trigger signal. Select line 3 in the line selector. Now you can control your light by selecting on or off in the output line source. You can leave the output line pulse delay to 0, but I recommend you do not leave the pulse duration at 0 if it was set to 0 by any chance. For just triggering the light, 1 or 2 microseconds is good enough. It's not necessarily to be set too large so that it might mess up synchronization between camera and light. If you are going to control the light on time with this pose, then you can set the period appropriately. Make sure it's not exceeding line trigger period. Thanks for watching. Hello, let's take a look how to configure the exsync via camera I/O Linea ML multi-line color camera. This segment shows the frame graver's parameters, and the below segment shows the camera parameters. Click the digital I/O control and select the external in trigger mode. There are three options in trigger source. CLHS in, which is exsync from the frame graver. Loader encoder, literally exsync from an encoder. And line 1 is a GPIO exsync channel, which accepts TTL type signals, including signals from a loader encoder. You may have a question, what's the difference between the loader encoder and line 1 then? The loader encoder generally outputs two phases, phase A and phase B. With their logic relationship, an application system can distinguish the direction of rotation, whereas the line 1 can't. Let's choose line 1 first and choose the rising edge. The exsync is working. Let's select loader encoder now. I've connected phase A and B to pin 5 and pin 6 respectively. Of course, encoder signal ground and camera signal ground are connected as well. Leave the rising edge clockwise and motion as they are. The exsync is working well. Now change the encoder direction to counterclockwise. See if it's working or not. It's still working. Now change the direction to clockwise and change the encoder output mode to position. It's working too. Change the encoder direction to counterclockwise. The elbow becomes red color. It isn't working because the direction option I've chosen in the interface isn't matching to the real direction of rotation. Change the direction to clockwise. It's working now. The position option in the encoder outputs mode senses the encoder rotating direction, whereas the motion option is just reacting to all the signal edges and ignores the rotating direction. Thanks for watching.